All right, hello everyone. This is the lab portion for chapter 7 and part of the muscular system for the musculoskeletal system in your Carolina Biological lab kit. So we'll be dealing with the skeletal model. Okay, so make sure you have that put together. And I'm going to be walking you through examples and sharing with you also the example lab manual that you'll be turning in for this particular lab. Okay, so just be forewarned, it does take a little bit of time. So make sure you're ready, and hopefully with the examples that I give you, it'll go pretty smoothly. Okay, so this is for week 4. This is your hands-on musculoskeletal system lab that you'll be submitting as your lab assignment for this week. We'll be divided into 2 parts. This first part, we're going to cover just the skeletal system, and then the second lab video I'll do will be the muscular system, but I will show you the lab notebook kind of all together. All right. So let's watch this quick video real quick together. Okay, so the full length mirror is specifically for activity 7. If you want to record yourself or take a picture of yourself doing the muscular movements, that's why the mirror is an option there, if you choose to do that. It's pretty easy to put together. And then for activity 1, you'll see we're going to be labeling long bones, short bones, those kind of things. Mm-hmm. Yeah. So that's what the full length mirror is for. For activities 6 and 7, you can demonstrate those joints, excuse me, identify those joints or demonstrate those movements on yourself. You will have to only simulate 2 of those. The one shown was the bicep, tricep, and there again, you can demonstrate those on yourself or the model. Okay, so that is up to you. All right, so let's begin. When we look at the skeletal system, we see that it has an axial portion and a appendicular portion. So bone, well, let's get back to bone first. Bone and cartilage make up the human skeletal system. It is the primary functions, as you see here, to support the body, to protect organs, store minerals, and provide leverage for movement with the muscular system. So the adult human body has about 206 bones, can be divided into 2 parts. Here you see the axial skeleton here, which is your protection, bones, as you see here in pink. So the cranium, the sternum, the costals of the rib cage, the vertebral column here, both the cervical, thoracic, and lumbar. I do recommend as you go through, if you want to click on these tabs here, it does identify each one of the parts here. And then you have the appendicular skeleton here. Think of the appendages, okay, your arms and your legs that provide movement. When we look at bone tissue itself, there are two types of bone. You have your compact bone, okay, which you see here. It's typically the white of the bone that you see when you see bone, and then this inner spongy bone, which is found on the proximal and distal epiphyseal ends of the bone, where you have hematogenesis, you have new stem cells, new blood being made here within the spongy bone. You also have, you'll remember from lecture here, you have the osteons here with the Haversian canals that allow the vasculature within the spongy bone. And when we looked at long bone anatomy, you saw the foramina where these vessels go into the Haversian canals here within this particular portion of the bone. This is simply an example here of cartilage and how it acts as a cushion and a protector. Here you see the femur, the fibula, the tibia here, and of course your patella. Right? So your knowledge checkpoint here, which of the following is not a function of the skeletal muscle? It does not produce muscle cells, okay? The skeleton does protect organs by way of the axial. It does store minerals in way of calcium, mineralization, your osteons, excuse me, your osteoblasts and your osteoclasts that help maintain that. Does help support the body and leverage movement with the muscular system. When we look also here at bones, the different types of bones within the human body, and these are the ones you're going to need to identify. This is, I think, activity 1. So long bones are classified not always because they're long, well, they are long, but the length of the bone is greater than its width. Okay, so we think of the femur, okay, as the longest long bone in the body, and it is, but not all of them are going to be extremely long. They're simply longer than they are wide. Then you have flat bones that are flat, irregular bones that have no real even shape. You have short bones, and then you have your sesamoid bones that's embedded within a tendon as your patella, or known as your patella. We'll come back and talk about these different ends here a little bit late. Well, let's go ahead and do it. This picture is not a very good picture, so you can go back to your lecture video and your textbook and actually look at much better diagrams here of the different ends. So you have, this is the femur, so you have your you have your femoral head here, the greater trochanter, which is going to be on the proximal epiphyseal end. So proximal simply means closest to attachment point. Distal means farthest away from attachment point. So you have a proximal epiphyseal end, a distal epiphyseal end, and then the diaphyseal end, or known as the shaft here, okay? Your epiphyseal line, this is where you're going to have your growth plates. And remember, meta epiphyses simply means next to. So when we're looking at the general anatomy of a long bone, that's what we're looking at there, okay? Within the, there's not a good picture here either, but we'll go back to this one here. You see the red bone marrow, excuse me, that is housed here within the spongy bone on the proximal and epiphyseal ends of long bones. Okay, so when we look at this x-ray here, it's asking which part of the bone is broken. So you see the proximal epiphyseal here, the distal epiphyseal here. So we know it's not those two. It's right here in the diaphysis. Okay, it's right in the middle. So this will be the diaphysis line. Proximal epiphysis would be up here. The epiphyseal line would be right beneath it. The metaphysis would be in between the epiphyseal line and the diaphysis. And then, of course, this is the distal epiphysis here. Excuse me. When we look at some common bone features, so there again, this is in your textbook, and I'm sorry, I should have the exact page number. I'm sorry, I don't have that in front of me. We'll be looking at some of these in closer detail in lecture. Just know that you're going to be identifying some of these common bone features. Articulation feature known as a condyle. This is going to be a curved prominence. A crest is a narrow ridge. The epicondyle is the epi meaning on top, so it's going to be in proximity here to the condyle on a bone. A foramen or foramina is the opening that allows vasculature into the bone for the bone marrow and the blood and all of that to get in and out of a bone and to maintain the overall bone health. A fossa and a head are bone prominences that aid in articulation. We'll be looking at some of these as we go through. Rami is the branch-like projection, such as your mandible or your lower jawbone. We're going to be looking at some of these as we go through. So just be a little bit familiar with those terms. Then also when we look here at joints and how bones articulate or come together in a joint, you have different types of joints. This is also what you'll be identifying in your lab. You need to identify at least one fibrous joint, one cartilaginous joint, and at least 3 different types of synovial joints. And I will give you examples of all of those, okay? So your CR3Cs joints here, these are immovable, known as your sutures, such as the bones of the cranium, such as the coronal suture on top. Your M3Cs joints here, these are slightly movable, such as those in between the sternocostal cartilage of the rib cage or the cartilage in between the vertebrae. And then you have your diarthroses. These are your fully movable joints known as your excuse me, your knees and your elbows. And then there's different types of your synovial joints that make up those fully movable joints. Okay, so which of the following structures best identify diarthrosal joints? And you see here, those are your freely movable. So the only ones here that are freely movable, right? Are going to be your finger knuckles. Okay, your phalangeal joints. Just a little bit of background here on the muscular system. Yeah, I guess I'll go on and go through this. I was going to save muscular for later, but let's go on and let's just go in line. So your muscular system here works with the skeletal system to provide leverage. So when we look at that term leverage, a lever is a movable rigid bar. As you see here, your radius and ulna here is going to be that lever, that part that's going to be moving, flexing, and extending. And that force is applied on the fulcrum here. Okay, so it's the muscular system aids in that particular leverage and movable joints here. So the contraction here of the bicep is going to flex the arm. That contraction of the tricep is going to extend that arm, providing that that force. When we look at the where muscles attach to bone, that's known as origin, insertion, and action. So where a muscle originates, okay, this is the proximal end. Let me give a good example here. Yeah. So muscle origination. So you see here, this is the shoulder. Okay, and you see the bicep is going to originate closer to that attachment point here of the scapula. So it's the more proximal end. It's the less movable end of that muscle when the arm is flexing or extending or doing circumduction. And usually it is less movable compared to the bicep insertion here, where it's going to insert or attach at the most distal end, as you see here on the radius, is going to be the most movable end of the muscle and usually less massive. Okay. So when the muscle decreases the, oh, and yeah, you can see the definitions here if you want to click on those. If there's a term you're not familiar with, then simply click on that term and it'll give you that definition. So the bicep is a flexor, which means it's going to decrease that angle at a joint, which means you're bringing your wrist to your shoulder. Okay, that movement is flexion, and then going back to original position is extension. Okay, so an extensor muscle going back to origination, such as your tricep, the insertion point, okay, the most distal point is being pulled away from the origin point. Okay. Might take a little bit to understand that. So spend a moment there understanding origin and insertion. And the biceps and triceps are one of those that is really good at that. Muscles work in what we know as antagonistic pairs, meaning you have your bicep on the anterior surface of the body that's going to flex the arm, and then you have your triceps on the posterior aspect of the body that are going to extend the arm. The bicep and tricep are an example of an antagonistic pair. Muscles only contract, okay? They don't push. So in order for you had to have full range of motion, you have to have those antagonistic pairs, one that's going to pull on one side of the body or yeah, either front or back, and then or middle or side. Okay, you have medial muscles, lateral muscles, anterior muscles, posterior muscles. So they work in what we call antagonistic pairs. Okay. So your kit here, we'll dive in. Okay, so you're going to need your skeletal model put together, your string and your tape. Optional here is going to be, well, you're going to need your camera because you're going to have to take pictures, but optional is going to be the full length mirror if you choose to do the motions uh, on yourself. Okay, both are fine. I just need pictures of them. So let's go through your pre-lab questions here. I think I already did that. So before you can progress, you need to answer your pre-lab questions. Let me know if you have any trouble with those. So when we're looking at your skeletal model, okay, when you have them all put together here, activity one is you're going to need to identify different uh, types of bone, okay? So for activity one, you need to identify a long bone, a flat bone, an irregular bone, a short bone, and the sesamoid bone, excuse me. Okay, and this is simply just giving you the difference here between the axial and appendicular skeleton. Remember, axial protects, appendicular moves. All right. So, so that's activity one. And I'll show you pictures here in a minute. I've gone through the lab and done it myself. Okay. So I'm never going to ask you guys to do something that I don't do myself. So I'll show you my results here in a second. Activity two, you're going to identify different types of um, uh, um, flat bones. Okay, so here for activity two, you can do the frontal bone, the parietal bone, the um, um, occipital bone. Okay, whatever you'd like to do there. These are all good examples here. I would just kind of stick with the easy stuff. You know, give me the parietal, give me the frontal, give me the occipital, give me the rib, you know, a costal. It's fine. Activity three, you're going to be identifying irregular bones. Okay, so irregular bones are going to be those of the vertebral column, the sacrum, the coccyx. Okay, so all of these here are going to be types of irregular bones that you're going to show me. Okay, so the vertebrae is irregular, the sternum could be irregular, coccyx, sacrum, all good irregular bones you could identify. This is a good example here of the clavicle, which is part of the appendicular skeleton. Actually, students sometimes get that confused. But notice here you have the sternal end, which is this flat aspect here. And you see the acromial extremity part here that's going to articulate with the scapula, specifically the acromial process of the um, scapula, which let's take a brief moment to look at that here. Oh, I want to go back real quick. I'm sorry if I can. Go back real quick here to the ribs and make sure you understand you have these vertebral sternal ribs known as the true ribs. And you'll notice this on your skeleton. Notice how they attach both to the vertebral column and directly to the sternum. Okay, these are your seven, your true seven ribs, and they are your vertebral sternal true seven ribs because they attach directly to the vertebrae and the sternum. Then you have what's known as your vertebral costal ribs. These are three pairs that articulate with costal cartilage first. Okay. And then you have your floating ribs, or known as your false ribs. Or excuse me, true ribs, false ribs, floating ribs that only articulate with the vertebral column. They mainly help to protect your kidneys. All right, moving on to the scapula here, you see your supraspinatus fossa here. This is one of the uh, major muscles of the rotator cuff group, and it inserts on the, or excuse me, the supraspinatus muscle inserts here on the greater tubercle of the scapula. This is the posterior view. This is a lateral view. Okay, you see here this glenoid cavity where the humeral head is going to articulate into, um, and mm, and then, yeah, your infraspinata here, fossa, where you're going to have the teres minor and other muscles of that shoulder girdle are going to insert and originate there. Moving on down, you have your humerus. You see the humeral head that's going to articulate with that glenoid fossa we spoke about right here of the scapula. Okay, you see the lesser tubercle, okay, the smaller projection here, the anatomy neck here, um, uh, anatomical neck here, and the surgical neck here is one that is usually broken when people break their humerus. It's one of the areas that is more likely to break. These greater tubercles here and the intratubercle groove, these are all different origination points, okay, of different muscles. And then when we're looking down, you see your trochlea here that's going to articulate with the ulna, and then your capitulum here that's going to articulate with the radius. These distal end humeral features, your trochlea and your medial epicondyle here, okay, aid along with that supination pronation movement with the radius. Speaking of the radius here, the way you can kind of tell these two apart is the radius, the proximal end of the radius is always going to have this radial head, this pivot point that allows that supination pronation movement. And your ulna here is going to have the olecranian process here that's going to articulate with that trochlea of the humerus. So allows for that hinge movement here. Okay, so that trochlea notch is going to embed right in here, okay, within the distal end of the humerus. So I want you to really look at that when you're looking at your skeletal model and, have it flex and extend that elbow joint and look at that. The bones are shaped for a reason. Then you have these two styloid processes here, your radial styloid that's going to articulate with the scaphoid of the carpals, and then your ulnar styloid process that's going to articulate with the lunate. Speaking of those, you see those here. Okay, so you see your lunate, you see your scaphoid, your carpal. So these are the bones of the wrist. Okay, not the bones of the palms. Those are the metacarpals, the bones of the wrist here. And there are 8 of them that you see listed here. Okay. And also, when we're looking at the fingers, I want to draw, or the phalanges, I want to draw your attention here to how they are numbered and the bones within them. So the wrist, your carpals, your metacarpals. Notice the Roman numerals here, 1, 2, 3, 4, 5. This is how the digits of the hand are labeled. So your thumb is first digit, then second, then third, then fourth, then fifth. Remember anatomic position, the thumb is always going to be lateral. And you have your distal phalange, your medial phalange, and your proximal phalange. Okay. Proximal, middle, distal, proximal, middle, distal, proximal, middle, distal. Except when you get here to the thumb, notice the thumb only has a distal and proximal, does not have a middle. Okay. And you can look at your thumb right now. If you bend your thumb, you see only one joint. That's the joint right here. When you bend your digits 2 through 5, you see 2 bends. That's because of that middle phalange, that middle phalanx there in the phalanges. Okay, moving on down to the pelvic girdle, you have your cocci here, or your hip area. I want you to look at some of those major features here on your skeletal model. Mainly the ilium, okay, that iliac crest, this greater sciatic notch here that is important for allowing the sciatic nerve and the piriformis muscle and some gluteal nerves to go through there. Your acetabulum here, this is going to articulate with the femoral head. You see the rami here of the uh, um, pubis, the pubis rami, the ischial curve here of the ischium. Okay. So make sure you're familiar with those major areas of the coaxial or the hip bone. This is a lateral view here, and this is a anterior view here. Okay. We'll talk a little bit more about that in lecture. Okay, you can read through those. Moving on down, you see the femur, the greater trochanter notch here, which is the articulation point for a lot of thigh and gluteal muscles. Lesser trochanter also an origin point for muscles. Um, the diaphysis here of the femur, the proximal epiphysis, distal epiphysis. The distal epiphyseal end of the femur is going to notice you have a patellar surface here, and you see the patella and how it's shaped with the pointy end is going to be distal or point inferiorly. This apex point here is going to be inferior, and how it is a sesamoid bone. So it's going to be embedded within the tendon. Okay. Moving on down, we have the tibia and the fibula. Remember, the fibula is always going to be lateral. The tibia anterior surface is always going to have this tibial tuberosity here. And you're going to also be able to tell the distal end of the tibia and fibula because of these malleolus and kind of like stylus endpoints here. The tibial medial malleolus is going to articulate with the tarsal, the ankle bone, the tarsal, and the fibula, lateral malleolus here is pretty, it's pretty distinctive when you see it on your skeletal model. You'll see that articulate with the tarsals as well. All right. Yeah, medial condyles. This is going to be the medial. This is lateral. Yep. Stylus is going, the medial malleolus is going to be on the medial aspect. Medial and anterior, you'll see that crest there of the tibia. And then lastly, before we get into the actual lab notebook, you see the feet, okay, your foot and ankles. So the bones of the ankles here, the distal extremities, The tibia and the fibula are going to articulate here with the ankle and are known as the tarsals. You have your metatarsals here that make up the foot, okay? So you have your ankles, you have your foot, and then you have your phalanges. Let me zoom in just a little bit on those. Okay, let's look at this anterior superior view first. Okay, so you see your tarsals here, the calcaneus, the medial, intermediate, and lateral cuneiform, and the cuboid tarsal. Your metatarsals, 1, 2, 3, 4, 5, make up the main aspect of your foot. And then you have your phalangeal bones, digit 1, 2, 3, 4, and 5. And just like the hands, you're going to, or the fingers, excuse me, yes, they're also known as phalange, but you're going to have a proximal and distal phalange for your big hallux, your big toe. And then you're going to have a proximal, middle, and distal phalange for digits 2 through 5. So your thumb and big toe only have proximal and middle phalange. The rest of them have, excuse me, did I say that right? Proximal and distal phalange. The rest of your toes and fingers have a medial phalange. This is a lateral view. Okay. Now, let's get into the nitty-gritty. Activity 6, you will be showing or putting in pictures of different types of synovial joints, cartilaginous joints and fibrous joints. So these are the examples of the synovial joints. You only need to pick 3. Okay, and then for activity 7, you will be showing me any of these rotational movements of joints. There again, you get to pick, okay? This is an example. You can take a picture of yourself doing elbow flexion and elbow extension, okay? Or you can do it on the skeletal model, perfectly fine with that. You can take pictures of yourself doing a shoulder flexion and extension here. I'm fine with that. You can give pictures of yourself doing cervical flexion, cervical extension. This is an example here of knee flexion, knee extension. And you can do any of these you choose, okay? Or you can also model them on your skeletal model, whichever you prefer to do, okay? You only need to do 2. So if you want to do arm abduction and arm adduction, that's one of your 2 movements, okay? Might be quicker to just do them in a long view mirror yourself. Or here you can use the string and the tape in activity 7 to show me that flexion and extension. Here in activity 6, you're showing me joints. Okay, so you can show me that type of joint or the movement of the joint. Okay, so let me show you some examples. Here's the lab notebook and I will also upload this into the Canvas page so you can see my pictures. The only caveat is, and I've labeled, let me show you an example. So this is activity 1, where you're going to be identifying a long bone. Okay, I've given you several. You can pick any of these. Notice too how I've labeled them. Clavicle, LB for long bone. Humerus, LB for long bone. Ulna with a U, LB for long bone. R for radius, UB or LB for long bone. You can abbreviate phalanges here for long bone. Okay, I'm fine with that. So if you want to abbreviate, I'm fine. Just remember, I need to have some form of identification in your picture. Okay, so don't just copy and paste another friend's picture or one off the internet. It has to have your name somewhere in it. Okay, so that way I know that you're doing your own work. Okay, so you see this example here. I know it's me, and this is activity 2. These are flat bone examples. Okay, coaxial or coax here, flat bone. You only need to give me 1. I've shown you 5: frontal, parietal, sternal, costal. Okay. Here's irregular bones, lumbar vertebrae, sacrum, coccyx, ischium. All of those are examples of irregular bones. IB. Okay. Short bone examples, carpals. Um, there's more. I guess I only did, because I wanted to put these in the same picture. So carpals are an example of a short bone, and then patella is the seismoid bone, or seismoid, yeah, bone example. Okay. So that's activity 1 through 5. For activity 6, you are giving me examples of joints. There again, you can use them. You can take a picture of yourself and upload it with, and notice here I'm using the tape that was provided in the lab kit. Okay, so this is an example of a fibrous joint. You have your coronal fibrous joint. You have your uh, syndesmosis fibrous joint here that connects the ulna and radius. Okay, that can be examples. There's others, so you pick. These are examples of cartilaginous joints. Okay, so pubic symphysis, the sternocostal joints here, synovial joints, there's tons. So there again, you can label them either on the model. Remember, SJ means synovial joints, and these are the different types of synovial joints. You have your hinge joint here, the knee hinge joint, the saddle hinge joint of the thumb, okay, the hinge joint of the elbow, the ball and socket joint of the uh, shoulder. I don't really care which one you choose. Just give me 3. Okay. Any 3. I've given you well over 7 different examples here. You only need to give me 3. And then lastly, you will be inserting a picture, 4 pictures total of either you doing the movement yourself or you doing the movement on the model. I chose to do the movement on the model. So you see here, I chose to do bicep and tricep antagonistic pair movement of flexion and extension. So I have my name there. You see my origination point here of the bicep. You see the insertion point here of the bicep. So this is the tricep in extension. I did not label my tricep because it's on the back. My string here is showing the bicep in relaxation, okay, which means the tricep is extending, or excuse me, the tricep is flexion to provide this arm flexion, this lower arm, excuse me, lower arm extension is what I mean, okay? And then the opposite of that is where this bicep contracts. Okay, so you pull on your string, it's going to cause this forearm to flex. So you're decreasing that flexion or that angle of the elbow joint here. So there again, you give me, let me see if I can go back real quick without, I don't know if I can go back without leaving the lab manual, which I don't want to do right now because I want to show you how to download it. But remember the pictures earlier in the video of where you can take a picture of yourself. There again, you can take a picture of yourself doing any of those muscular movements. I will take them. Okay. Lastly, when you are ready to download your lab notebook, remember, because we've been working in your lab notebook. Okay, see, I've been uploading these pictures here. Notice how I uploaded these pictures. Okay, you can browse. Okay, browse your computer, upload your image here. Okay, when you're ready, oh Lord, which one was my fibrous joint? I shouldn't have done that. But I have it saved. I'll upload it. When you are ready, you're going to go here to print. Okay, and then you can either print. You're going to save it as a PDF. Don't print it to your home printer or the school printer. Save it as a PDF. Okay, click save. And then you are going to save it. Okay, class example, lab note, lab manual, and it has all of, and click save, okay? And it'll save it right to your computer, and then you will upload it into the assignment within the course Canvas page. Okay? Please email me if you have any questions or concerns. This lab does take a little while, a little bit of time, so I recommend spending a couple of days on it to make sure you can upload everything into the lab manual. Let me know if you have questions or if we need to do more videos together. I'm happy to help you. Thank you.